Hello, everyone, and welcome back to the Cybernetic Economy podcast. My name is Stepan Gershuni, and today I'm your host. As usual, in the Cybernetic Economy podcast, we discuss how rapidly evolving technologies, such as artificial intelligence, robotics, and blockchain, are going to impact the world that we live in. How are they going to change the society and the world economy? Today, we're discussing the future of decentralized and user-owned AI. As usual, this podcast is brought to you by Cyberfund, where our mission is to invest and enable healthy transition to the cybernetic economy. Please make sure to like and share this episode if you enjoy it, and I hope that you like our podcast. Hello, and welcome to another episode of the Cybernetic Economy podcast. Today, we are recording a new episode with Illia Polosukhin. We are in San Francisco, and we are going to discuss AI and blockchain and intersection of decentralized technologies and artificial intelligence. Illia is a researcher from Google who was one of the co-authors of the Attention is All You Need seminal paper in machine learning that led to creation of ChatGPT and many other very popular tools and products. He's also founder of Near Protocol and now working on Near AI. Hi, Illia, and great to have you.
Yeah, thanks for having me.
Yeah, so I guess first question for me is, you have this very interesting journey. You worked in machine learning, AI, you contributed to this work on transformers, and then you switched to building blockchain. You built successful blockchain, one of the top projects in the world, and now back building an AI. What was the reason for you to make such radical shifts, and what led you to working in the AI in the first place and now getting back there after all these years?
For sure, yeah. So I've been kind of excited and interested in AI from very early age, like 10 years old, when I learned about the concept, and obviously been watching a lot of movies, reading a lot of books, everything from Asimov to, more modern authors. To me, AI always seemed like kind of a natural evolution of how humanity is gonna effectively evolve itself, right? And I mean, we'll talk about more wider implications, but kind of more practically, I thought always that as soon as we can teach machines to code, we'll have effectively a new way to interface with computing, and that in itself going to change and unlock massive amount of value, research, and kind of advancement to people. And so I've been trying to do that since I was like probably 15. Obviously, it'd been failing because the technology didn't work, but through doing that, I've kept learning more about machine learning. I worked at a kind of pre-neural network machine learning company that was kind of powering a lot of the decision trees, random forest, etc. And then when I saw the paper, the cat neuron paper that came out of Google in 2012, I got really excited because to me that was a first example of neural network learning something without explicit supervision. And I was like, okay, I want to do that. I think neural networks are going to be the future. And its time is now. Now, at the same time, I actually thought that images are, there's thousands of species that can see, and there's only one that can talk. And the only way we know that somebody else is, intelligent, is able to understand you, is able to do things, is by having a conversation, by asking questions. And so I joined Google, the team that was doing question answering, because of this. Like, I thought natural language understanding through question answering is the way to effectively advance the overall kind of toward AGI. And so at Google, we had obviously really, sizable resources to run kind of pretty sophisticated models, and you still want to launch something. And so we had challenge launching actually the models we would build with recurrent neural networks in production because they were too slow, right? And Google.com has, very famously very low latency requirements for all the responses. And so what we usually would do, we would distill kind of sophisticated recurrent neural network models into a bag of word model. So very basic model that doesn't know anything about the sequence of words in a sentence or in the paragraph, and then just use that as like a scoring mechanism for question answering. And that actually was not bad. Like we had that in production. It was answering some questions for people. But obviously, it was missing a lot. And a sister team that was kind of under the same director, they were working on a related task of query similarity. So how do you take two queries and understand if they're similar or not based on the kind of signal from Google itself? And the way they were doing it, because they needed to do it extremely performantly, because this is the biggest data set Google has, is by just effectively so-called dot product, like multiplying two embeddings of each sentence to each other, and effectively kind of each word attending to every other word in another query. If now that we know the attention word. And so at some point there was a discussion which is like, hey, we have this question answering system that is effectively trying to read one word at a time. It's too slow. It's too hard to train. There's a lot of issues with exploding gradients and all kind of other practical training problems. What if we drop the recurrent part and use the same principle of, one sentence attending to another, but that sentence is the same? And so that's kind of the concept of self-attention, right? Where effectively you're comparing sentence to itself that gives you a semantic kind of resolution between how different words in a sentence relate to each other. And you can do that extremely fast because it's super parallelizable. And so you can do it multiple times. Like if you do it only once, you get one level of relationship. But if you do it multiple times through a few layers, now you actually can have pretty complex relationships expressed. And so was kind of the original idea behind Transformer. I coded up after lunch of the discussion. It wasn't random. It was starting to pick up some signal. And then there was massive, obviously, effort to make it really work, really scale. And, there was a lot of experimentation. A lot of really important things were figured out around how to stabilize it, how to kind of do gradients, etc.
Did you initially set to build something like large language model to actually train it on large corpus of data, or the first goal was?
So the first goal was just to see if this structure works. And so we were testing it on machine translation tasks. So you give it German, you want it to translate to English. And again, this is a model that doesn't from perspective of, before, it's a model that didn't know anything about the sequence of words. It wasn't reading one word at a time. It was consuming the whole text in general. So the fact that it started translating something in was already surprising. But yeah, it was in general, our team was training on large corpuses and kind of pre-training on RNNs on massive corpuses. So that's not, I wouldn't say that was outside of norm to train kind of even just a general language model with RNNs before, and then kind of tune it on specific.
So that was always the goal, but it took the next 3-4 years to actually get to performant and capable models like GPT-3 and...
Yeah, and I think the important part, obviously, OpenAI and different Illia betted a lot on just, hey, we just need scale, right? I think usually as a researcher, it's a very... it sounds very lazy if you just say oh, we just need more data, right? As a researcher, you want hey, we need a better architecture, we need a different way of training, etc. And Illia very, I would say, courageously and kind of was deep inside, right, said hey, we just scale this and we need more compute and we need more data to do that, cleaner data, obviously. And the reality is 2017, when transformers were invented, there was no compute available. That much of compute wasn't a thing, right? Obviously you can combine that, and Google has, but you wouldn't consider doing that for large runs. So yeah, I think OpenAI did amazing work on just making this possible and showing that this is the thing that actually works.
Yeah, and kind of bitter lesson came out, I think, a couple of years after, which now considered to be like a rule or almost like a rule in machine learning, and people try to apply it everywhere, even where it doesn't make sense, where you cannot solve things with just scale.
I mean, I think that the so-called scaling laws, which are not laws but like principles, and so they, like, the fact that like people have tested that and validated that indeed if you grow the size of the model and increase the amount of data it's trained on, and obviously like there's a lot of magic involved in getting all of that right, but you actually have a consistent increase in performance of the model. Like that, the fact that like that was the hypothesis that was tested and evaluated, I think that was a deep insight, which again, like normally as a researcher you would be like, I want a better model, right? Not like, hey, well, let's just put it through more compute. So I think that was a deep insight kind of that followed and kind of unlocked the next stage of this.
And as we're talking about it, do you think that today there is other ways or other potential for similar scaling laws, maybe in multi-agent systems or some non-transformer based architectures for large language models or like video models?
Well, I mean, we are seeing already some form of that with effectively like reinforcement learning, right? Like right now, right now you effectively can train with reinforcement learning a reasoning model and it becoming better, and then you can actually distill the reasoning model back into a non-reasoning model, make that better, and then do it again, right? So R1 V3 actually are trained in a loop. So there's actually no base V3 which is not trained on R1 output. It's the one they released, at least as far as I know, is already trained on traces from R1. So it is actually smarter because R1 was trained with reinforcement learning based on the previous version of V3. And so it's a loop that continues improving.
And there's a question, like, is it like human intelligence in kind of like this? Like we have the same level of intelligence, same biological system, and then we keep discovering new science. So it works with humans, but also there's just like some distribution of data and knowledge that you have in the large language model, and typically it doesn't go outside of distribution. Like, what do you think? Can we have artificial intelligence in very near future based on large language models that can actually think for, I don't know, days or weeks and discover new science and knowledge?
There's already, I mean, papers that are in a narrower domain show that this is doable by effectively, I mean, so there's few concepts that's important to understand. What transformer does internally, like, I mean, all neural networks kind of do that, but transformers especially has like an inductive bias around effectively maintaining a multidimensional search space. So like the transformer itself is a search system inside, but indeed it's mostly constrained by its training data. You can unconstrain that, right? So like what effectively the reinforcement learning like O1 and DeepSeek R1 have shown is if you are sampling multiple times, one of this time will hit outside of what like this model normally shows you, and you can use that example to reinforce that behavior, right? So that's already an example of effectively using like search, right? That this transformer maintains multiple possible probabilities of the outcomes and sampling out of that to find a approach that actually gets you to a result you want, and then reinforcing that. And so you can effectively train it and improve it in those different behaviors, right? So math, physics, coding, and that then translates, as we see, to like all other aspects, because it's starting to kind of think a lot clearer and kind of, instead of, getting lost in its own thoughts. But if you kind of, push this further, like one of the things that none of these models so far are doing is effectively posting hypothesis and testing it with a real environment, right? All of this right now is effectively, you kind of, if I would, ask you to generate 100 hypotheses and then tell you, okay, one of them is good, right? That's like, and this is the only way you explore the world, right? That's a very limiting signal, versus if you posting hypothesis, testing it yourself and have that feedback loop active, you can learn a lot more. You have a lot more information coming because you have like an active interaction. And so I think that's kind of the other piece that I think we're starting to approach, just because RL now works. For context, like the same methods were applied before and they just normally didn't work. Like there's like few different improvements that happened over past 6 months that made this approach actually work and very stable. And it now even works on very small models, right? I just saw a paper like somebody released the Qwen 32B is beating like 600B parameter models, right? Like somebody trained like a 7B model or 2B model. That's like, so we can see definitely like this approach scales and kind of works across. And so I think that like another evolution of that, where you have like an interactive loop with environment, will get really interesting, because then you're actually getting a lot more signal. So that's probably like one aspect. I think the other question you were asking is like, hey, other non-transformer models. So my kind of position on this is transformer model is about hardware. It's while we have this kind of hardware, and especially this hardware is getting better for transformers, it'll be pretty hard to have a different model architecture. If we have like something like Cerebras, and like it becomes a popular platform, you can develop a different model architecture for Cerebras, which will be more optimized for that hardware, and will probably perform better than transformers kind of trained on that architecture. So it's really, to me, kind of the question of the hardware. And because there's so much money effectively put into optimizing transformers, it's really hard to expect, like a startup to kind of outcompete that and develop architecture and, train it at large scale enough to show the benefits. That said, we didn't think you can like train a 7B model to become smarter than whatever GPT-4 a year ago. So everything's possible.
Yeah.
Like maybe Cerebras is actually training a better model now, and this gonna come out.
Yeah, I met a few interesting projects that are like showing surprising results, and everything is moving so much quicker. But it seems like there's an interplay between technology and research and economy, and you can have great idea, but if there's no economy to support it, if you cannot raise I don't know, hundreds of millions of dollars to train large models, or you don't have right hardware architecture which is widely available, then it's very hard to really commercialize and scale up. And that kind of brings back to the topic about blockchain, because blockchain is primarily economic technology. So you told me this story that you worked on transformers, then you wanted to do something in AI, and actually like finance and the financial system was the bottleneck.
Yeah, so I left Google because we've effectively had Transformer, we had, even the STMs were working reasonably well. And I wanted to see this in the product, and kind of my concern, and which was very much realized, is that Google had a kind of innovative dilemma of putting out kind of experimental products forward, and like very naturally, right? For Google, it's a massive liability to put something new, and if it doesn't work, they get blamed for that. And so the idea was like, can we apply these methods, right? This sequence-to-sequence models, transformers, to generating code from natural language, right? So as I mentioned, this kind of been my recurring theme. I tried it when I was 15. I tried it in my master's degree. And so we tried it in 2017. So we were pre-training models on GitHub. So we had like a language model pre-trained on GitHub, and then we were fine-tuning it we had training data from competitive programming, so Codeforces. And we kind of didn't have enough data, right? It was very small. So what we started doing is doing a lot of crowdsourcing, right? And, if you go to Mechanical Turk, the people in Mechanical Turk didn't know how to code. So it's not very useful. So we created our own crowdsourcing platform for people from Codeforces and from other places who know how to code, mostly computer science students. And we faced this challenge, which was we needed to coordinate them and pay them. They were in China, they were in Eastern Europe, they were in Southeast Asia. And, all of this had trouble like with monetary transition. So like we needed to OTC money into WeChat to pay people, because people in China don't have bank accounts. They have WeChat Pay, right? Ukraine didn't have PayPal, etc. Right? So like every country had like a different set of requirements and restrictions. And like, if you send dollars to Ukraine, you need to sell half of them right away and stuff like this. And so crypto seemed like a very clear answer. It's like, hey, we need a global payment network that's easy to program. Well, crypto is that. And so this already 2018, we looked into Bitcoin and Ethereum. And even back then, the fees were already higher than what we were paying people. And so it was kind of Well, it was higher than PayPal, yes, but it also was higher than what we were paying people. So it was like we
Well,
would double our costs just on fees. And so we were kind of like, okay, well, this doesn't make sense, right? This is a distributed system. Like this should support, more micropayments. And obviously being systems engineers, you read the papers, you like, okay, well, this doesn't scale, right? This is a very limiting design. We looked around and kind of looked at a lot of different projects that were existing or starting at the time. I didn't find anything that was like actually solving for the problems we saw. So like nobody was solving for kind of true scalability that is not bottlenecked at some point and kind of developer and user experience. And so that's kind of why we're like, okay, well, we can solve this problem. We know how to build distributed systems. My co-founder built a sharded database before. We know how to kind of scale the systems. And then we can, given we have this problem, there's a lot of other people who have this problem of, how to route money around and coordinate people. And so this will be extremely useful. And so that's kind of how Near became blockchain, focused on doing this. Now we were a little bit, how would I say, optimistic. We were planning to launch in 6 months. It took 2 years, but yeah, we launched it kind of mainnet October 2020, and yeah, since then been kind of seen obviously a great growth of the ecosystem from developers to users, as well as kind of really showcasing this benefit that network can continue scaling. So we actually just had a release that added 2 more shards to the network, and so effectively increased the capacity from 6 to 8 shards. And so like the idea is that network can continue growing with the demand, whatever demand is.
So now, are you mostly focused on Near blockchain or Near AI?
Yeah, so this is kind of that part of the journey. And obviously as, ChatGPT came out, my co-founder focused more time there, figuring out like what can we do. And he started kind of putting together a team where we kind of investigated like, okay, can we, well, first is like, what is, training? Can we do decentralized training? And so maybe from a higher level first, the challenge with the current situation, right, is that, I truly believe this is effectively the last technology that's gonna be developed by humans. Everything else will be developed by AI. We already see this, right? All the Nobel Prizes, so like a bunch of prizes have been won by AI researchers effectively in sciences, and it's gonna happen everywhere. Like the next doctor is gonna be AI researcher shipping a doctor model. And so, same with coding, right? Like it's really becoming true. And the challenge is like if it's all coming from one single company or like even a handful of companies, they effectively have like a massive power over all of this, economy and decision making, and they can, censor it, they can restrict it, they can, guide it into different ways. And so that's, coming from a very now blockchain kind of deep roots, right? You're like, well, this is not right. You really want AI to be on the user side. So you want it to be user owned. And then kind of through that lens, you want to build effectively the ecosystem around that. And so that's kind of when we started researching, okay, can we build a user-owned AI model, right? And the answer was actually no, because, right, back kind of over past couple of years, to train a model, you need like a massive cluster, you need it centralized, you need to kind of trust that every machine is, performing the job. Finish training, you just spend probably like a massive amounts of money. So either you open sourcing it and effectively not monetizing, or you're effectively building your own serving cluster and become another OpenAI Anthropic company, right? So like you actually have no choice kind of between like you're either unsustainable through open source or you're becoming one of those kind of closed source like projects.
So I think there's two things that are important in decentralized models and decentralized AI in general. One thing is that it's technical. Like, can it be done technically? Can you do efficient enough parallelism for training, for like pipeline parallelism? Does it work? Does it scale? And what kind of hardware requirements you have? And I'm curious, like what you guys think about it. And second is economic, like who owns it and who has incentives to control it, to give access or not give access, or withhold access, or use it for your own benefit. And like what's your thoughts on
So
both of
maybe
this?
before that, just to finish, like the reason why, kind of the set of reasons why we want to have a kind of a, like we call it user-owned model, is first of all, again, like you want to know what went into the model. You actually want to know what data went in, because there's always bias in any data. And so you want to know what the bias is so you can actually like correct for that if you don't agree with that bias, right? Somebody have decided to filter out, for example, Fox News. Now this is a very liberal model. Or somebody oversampled Fox News, right? This is a very Republican model. Like even those biases, like there's a natural selection that happens when you're training this model. So that's a really important part. The decentralization is actually important for a different reason, right? Because you don't like, right now there's 200,000 GPU cluster in Memphis. It effectively sucking all of the energy from that city. There's like exhaust in the air. So there's like a real challenges of like having massive clusters in one place, which are coming from electricity and kind of climate. And so you do want actually a way to coordinate decentralized compute, because like it's way easier to get 200,000 GPU cluster across whatever 100 sites or 20 sites than to get it all in one place. And so then it goes, okay, is it possible, and how to do it, and then what's the economics of this? There's been a bunch of research over past year, including by Prime Intellect and News, who have been showcasing that it is possible. There is different trade-offs that you coming with this, but there's a really kind of as well. I mean, original research came from DeepMind that it's possible to train across distributed clusters without synchronizing parameters all the time, right? Without having them in the same. So that's kind of piece number one. Piece number two, again, reinforcement learning, the current approach is actually way more susceptible for that, because you actually need to run inference for 100 times to get one training example, for example, because you're like sampling a lot to find trace that actually concluded, like solve the problem, and then you use that trace to.
So you take pre-trained model,
Yeah.
like Ren or DeepSeek or Llama, and then the decentralized network is like in parallel can do a lot of sampling and do post-training.
Yeah, for example. So there's like this approaches that came out over past effectively a year that now show that you can do a lot of this. So that's kind of piece number one. And then piece number two is indeed like what's economics and kind of security of this. Because if you just open this up to an open network, right, let's say anybody can join, the problem obviously, well, my computer, on a shitty Wi-Fi in a coffee shop, probably still not gonna contribute that much. But on top of this, if I'm now able to join this network, I can send malicious gradients, right? And I can screw up a model. And I can actually, whatever mechanisms, defense mechanisms built around that, they can actually, I can work around them to like bias the model in whatever way possible, like I want this. So even if you can do distributed training right now, going from distributed across multiple clusters to decentralized, where effectively you open it up, is still complex because of the effective verification problem, right? Like right now, verifying gradients, can be as costly as rewriting the gradient, right? And again, they're stochastic, so you actually don't even know. So that's kind of the fundamentals. And so what we've been looking at is like, okay, how do we solve that? And so one of the interesting things that happened over the last, again, 8-9 months is that it became possible to run so-called confidential computing on NVIDIA GPUs. So confidential computing is something that's been around for like a long time, but it never really worked. And so traditionally the Intel CPUs and AMD, etc., they all have this mode of confidential computing, but it's been extremely hard to use it, and it's like really different programming model. There was like missing assembly instructions, for example, in it, and in turn, it's also had like a lot of kind of security issues. So the new generation of Intel processors have this new mode, and same with AMD and the ARM, that just allows to run a virtual image of the operating system. And so now you don't need to rewrite your code. You don't need to change anything. You can literally take any arbitrary program and just run it in that. And you can verify that indeed that Docker container is running inside this mode. And effectively, the owner of the hardware is not able to access neither what's happening inside, like what data is being put or what execution. And so the only thing they can do, they effectively can just like turn off the machine. So you kind of have this like secure enclave inside somebody else's machines now that will follow the protocol. Now, a few asterisks, right? You're trusting the hardware providers with the like certification of keys. But for anything like machine learning, related, where we're not moving billions of dollars, this is actually really solving a lot of the problems that I was describing. Because now you can do a few things. You can train a model and know that the training nodes are following the protocol. They're not trying to, inject malicious gradients. And anybody can join who has the right hardware setup. You have now ability to, as you train the model, when you finish, the weights stay inside the TEs, trusted execution environments. And so nobody can access it without paying for usage, right? So now you have a sustainable business model where after you train the model, for people to use it, they need to pay. And so now you can actually raise money, through a token or traditionally, to build this model and then repay back from the revenue of this model being used. And the cool thing is this model still, you can run it on your own hardware if you have the right setup. You can fine tune it, and you can do a lot of other things on top of it, which you usually do with open source models. So it kind of have all the open source model properties, open parameter model properties, but it's monetizable. And effectively, you can almost think of it as DRMable, digital right management, where you can actually restrict, for example, that, if I train the model in my voice, I don't want it to talk about something that's not maybe AI related, right? So you can actually restrict what the model is used for. With it, again, pretty intelligent filtering because you have the access to the model itself. So you can have now a pretty interesting setup where you can have a community-owned model, right? So if you raise sort of token, some money to train this model, then the people who kind of have the token are now owning this model and receiving those proceeds, which they can, pay to itself, to the token holders, or reinvest back into a new model, right? So we can now have something that is, akin OpenAI model where you can continue reinvesting profits into building the next generation model. And that's where things getting interested, right? Because you also don't have any need for dealing with, GDPR, HIPAA compliance, because all of the, every interaction is fully confidential to the user who actually initiated it. And so now you have really kind of true AI that can be owned by community and by users, and then serve them, and if users want, they can optimize a loss function and kind of change, you can have a governance around what loss function you want to optimize for, which can be different from, for profit or whatever, depending on what community wants. So kind of we have this new economic model now to enable user-owned AI.
Yeah. So to sum up, user-owned AI is shifting incentives from large corporate. Like today, you either use model because you're paying for it to some big player, or because somebody decided to donate it. And DeepSeek or Qwen or Meta, they don't have to. They just choose to right now. And they can choose to not give out the next version. And user-owned,
or they can retroactively say you cannot use this anymore they can apply the change licenses. Yeah.
And then user-owned AI, it kind of gives, it makes it permissionless. So anyone can train the model. People don't need to give out the weights. It's not fully altruistic. You can actually monetize it. You can make money. You can have a small team that does very specific fine-tuning for models that is very good at, cookie recipes, and then get paid by people who want to bake cookies. And that is very interesting in terms with regard with what is happening in the economy. So you mentioned that probably a lot of things that we're inventing right now, it's happening the last time. I imagine today AI is much better than me in almost anything. I don't even need better model. GPT 4.5 came out, or Sonnet 3.7 or Grok. They know much more than I do, and they can do a lot of things much better than I do. And at some point, they will replace not just Google and question answering functionality. They will be proactive. They will become agentic. They will replace and augment functions in organizations. They might even replace organizations completely. And for me, the main question here is that what is happening with the economy then? Because AI significantly augmenting the production side of the economy, that is inevitable. Yes, marketing and legal and building websites and designing, I don't know, creating content for Instagram, that will be done by AI, and there's nothing tops this train. But the interesting question is how the economy can adjust to this change, because this change is much larger than what was happening before, and it's happening much quicker. And I think just today, Anthropic released this blog post saying that we will see models that are better than all Nobel laureates combined by the end of 2026. And I think they're not doing it just to PR, just because of the need for PR. I think they actually believe that this is happening, and we're here in San Francisco, and this is not an uncommon view, although it's not evenly distributed. So we talked about the model part, and I think the next layer on top is agents, like actual systems that people interact with, that build and help with economically valuable tasks. How do you see, and how do you think this user-owned or decentralized or permissionless aspect can work with agents and agentic system and multi-agent systems?
Yeah, no, I think as you described, these models are becoming more sophisticated, and in turn they can do more than just answer questions. They can actually do actions. And I think the important aspect to understand is that historically every type of automation humanity invented was effectively a tool that increased our own capabilities, like a tractor or a plane, a car, the factory producing like some like actual things that are putting together, right, our body cams, etc. But the transition we see now with these models is that they are able to make decisions, right? And so they are able to make decisions, and right now we don't fully trust them to do that, right? We kind of want to review it, we want to make sure that it's working correctly. But as they're getting better at that, as they are able to reason over more complex kind of contexts and know more about you, they'll be able to do it better and better. And in turn, that means a lot of the existing kind of, I would say, society that's built on effectively decision outsourcing is going to be reshaping, right? So right now, just to give a very kind of acute example, right, you have FDA, which is like we as society outsourced decision over what is a safe medicine for people, right? They receive information, they review it, and they decide, okay, this is safe, this is not safe, and they distribute it. And then you have doctors who are prescribe it at effectively different times. All of that can be done by your AI now directly, right? Both the doctor part and the FDA part can be done, and your AI can go and talk to AI of the pharmaceutical company and say, hey, based on the medical history of my owner, I need this and this, I need these compounds, I need, design me for a specific, modulations of the proteins. And you can effectively have a lot more personalized system where your AI is effectively on your side, kind of navigating the internet, the services and goods of the whole, around the whole planet. And AI doesn't need to look at the 10 blue links and whatever ads that Google shows, right? It will go and scan all the options and kind of find the best option for you. That's kind of where, our perspective is. We all individually will have our own AI assistant that is on our side. That's a must. I think if we don't have that, then we're pretty screwed. And so this AI assistant, this user-owned AI assistant whose goal is effectively to maximize your well-being, your economic success, your healthcare, is now kind of a firewall against all of the other AIs that are effectively our contraparties. And this is a very, I would say, blockchain thinking, because if you look at Anthropic's and OpenAI's, I call it a single player mode. Everything they build is a single player. It's effectively, you build they have products that are kind of you interacting with it as a person, and kind of everything around it is yours, right? So Anthropic Model Context Protocol, for example, it's a really good example. All of them are effectively, tools for your model to use your your data and tool and kind of software that you have on your computer. It's not, hey, how do I negotiate between two different agents where the other agent is actually has its own goals and is trying to make its own money and maybe represents a different person, a different company. And so that's where kind of this blockchain thinking comes in, where like everybody's self-interested and we need to find a consensus between all of them to really move forward and kind of get a win-win for everyone.
So current models, AI companies, they build agents, but those agents do not increase personal agency or do not give sovereignty in the world where coordination is happening not between people, but between primarily AI representatives of those people.
And so that's kind of where, we just released Agent Interaction and Transaction Protocol, AITP, as in HTTP for AI.
What's the difference between MCP?
So MCP, as I said, is effectively how do you get tools for your AI for kind of to use your services. AITP is how do different agents with different incentives and structures are communicating, negotiating, paying each other, requesting data from each other, potentially like, agent is requesting data that the other agent doesn't want to give, right? Like, how do you work around it? Like, all of that needs to be figured out because the privacy actually means that, like even scheduling, for example, this, right? We need to share some part of our calendar. If you just share like a full calendar, that's not good. So like, how do you share enough of information that we can find a compromise, but not enough to, now everything about my daily life, right? So those types of interactions, right, which are effectively happening now between, people, and like that's kind of what gonna move to agents, and we kind of need a protocol to do that.
So I'm thinking about this as increasing the resolution or increasing bandwidth, because people are good in creativity, in collaboration, but just from evolution standpoint, and historically it was limited to small groups, because majority of the like millions of years we lived in very small tribes, and now we have millions of people in the city and billions coordinating online, and we just don't have bandwidth for that. AI, on the other hand, they can discuss and make decisions and make governance decision or coordinate at 100 tokens per second, which is much faster than any person can do, and that is radically changing efficiency of the economy. Like we can achieve a lot, and you can I think the healthcare example is great. You can like today in the United States, there's about 50 new drugs approved every year, and that's not a lot, and there's much more going on in research, which is also AI assisted
Powered now, yeah.
growing and expanding right now. But I think there's also big question about how this transition will happen. So what is the end state? We can dream, we can discuss,
we can speculate,
we can
but
fantasize.
It's really hard to predict, because this is actually, if read science fiction from like 50, 60 years ago, it's really funny always, because people predict, okay, we're gonna have humanoid robots, but then they couldn't predict like iPad, right? There's like some things that are natural to us as extension like of what we see now, and there's some things that are like completely left field that like really hard to predict, and gonna be just different form factor, different shape, different experience.
I like this. There's a book called Why Greatness Cannot Be Planned. It kind of gives this machine learning analogy, and it's using machine learning analogy to describe philosophy of life. And basically it says that you cannot predict what will happen in your life or in society. It's just like this stochastic gradient descent towards somewhere. You just follow your passion, follow your interest, and it will happen. But yeah, back to the question. So it's very hard, like I cannot even realistically predict what will happen in 5 years from now. It's just technology will radically change. But the transition to this new economy, that's the important piece, because on the one hand, we have economy that's very inert, and most people in the world don't use AI or use it for very, very basic things. But technology is growing very quickly. And I see that there's a gap that is widening between technology capabilities and the economy coordination and institutions and systems that we use to to run economy, to coordinate. And do you think that decentralized or programmable AI systems can help solve this? Or do we need to rely on, politicians who I don't think understand this technology better?
Yeah, I mean they try now, right? There's a bunch of people in White House uh, trying to educate, but I think that there's a few different dimensions to this question, which all of them are important, and their interplay is unclear. One dimension is compared again to previous, especially like software innovations, when you're like an enterprise and you need to, uh, for example, get into cloud and use Salesforce and SaaS, right? You have to need to retrain your employees to use this new tool. It has like a some learning curve, and it requires a lot of kind of additional work to get this started. And so there is like a time lag between Salesforce adopted by startups and kind of few early adopters, and then like how it becomes kind of a majority used software and CRM more generally. With the current AI, even just the current state, I'm not even talking about future, you can already effectively outsource the whole, set of tasks. Maybe not jobs yet, but set of tasks, as if you had hired someone else, right? As if you had a person, and that person can talk to you on Slack and can respond to your emails and will read your docs and leave comments. And so it perceived as just another employee. So you don't have this like learning curve of onboarding your existing staff on the new tools. You effectively just have new employees joining who are working 24/7, who are now doing some jobs. And I think that haven't fully happened yet. I know a few of the startups who are like approaching it from this way, where say, hey, we're not anymore a tool for your company. We're an agency you hire. And you pay us as if you hired like a team of people, but we're going to work 10 times faster and 24/7 and, plug in all of your systems. So as if it was a person. So that I think will like hyper kind of speed up adoption of this technology, where we'll see like a whole job starting to effectively get outsourced to this AI agencies. And AI, anything that has agency in it probably can become an agent. This is the joke is, yeah, like anything that has an agent in a job title probably should be AI agent. So I think that's a one dimension, which is like kind of enterprise adoption will have a very different curve, which is as soon as it clears a quality bar where existing people feel like they're working with another person who can maintain context and can like respond to messages and reason, etc. I think that will just like really kick off really quickly. And this is where something on the product side we're building was like our agent hosting is kind of targeted at that, where you can effectively build these agents who are plug-in into your systems, who can talk to other agents as well to do the job. So like hey, I need a marketing agent. It can then through AITP go find other agents who will maybe do creatives and maybe do images, and then compose like a strategy of how to do the marketing campaign, and then run it through another agent, which actually does placement on Twitter and on Facebook, right? And then all of this runs inside confidential computing, so your enterprise are not leaking any of your private data to anyone, including developers of these agents. So that's kind of like one aspect. The other aspect, which I think is interesting, is indeed the kind of like the creativity. If you put it to the limit, right? Like right now, it feels like cool. Anybody now can build like a vibe code and app, right? And I think the old way of thinking about it is cool. Now that we're going to have a ton more apps. And I think that's actually outdated way. The right way is everybody will have their own apps. On more specifically, nobody will have any apps. You will just build software on the fly for the specific use case.
Just-in-time user interface.
Yeah. So even with agents now, we have a no-code agent builder, which you can build just in time the agent that will do the job you want. And you want to do that because you want effectively a more like predictable outcome. And so you like kind of materialize what AI could do anyway. You materialize it as a specific code, so you can like now run it continuously. And if there's some issues, you can tell it to improve it, or it can improve itself. So actually software becoming kind of more, of a thermal, like it's a thermal cache of effectively some reasoning and business process that, your AI is doing. And so that's, again, a very different mindset, because that means, your phones and your devices are just becoming AI. They don't need apps, so they need websites, which also means you don't have marketing anymore. You don't have ads. Like all of that is also disappearing kind of with that, because your AI is now on your side, will not let any ads, like unless there's a explicit exchange of value where I see an ad and then I get something that like otherwise I wouldn't see. So you have like a very different interaction that's gonna like start appearing from that. Now that is a little bit longer term, but again, this is where like the economics is gonna start like changing, because all of the technology, all of the business processes, all of the interactions we have right now kind of build on top of the kind of this like software.
I think it's actually, it's not evenly distributed, but it's happening right now. I just saw a demo, which is actually used in production by the company who builds it, of basically Cursor for finance and for marketing. So they have something like ID for people who don't need to code, who just talk to this system that has a bunch of MCP servers that are connected to internal tools, and then it builds dashboards. And basically, from what I've seen in this demo, they are saving at least $200,000 to $300,000 per year on software as a service.
On SaaS, yeah. So SaaS is cooked for sure. That's just this is happening. But I think like it's actually gonna be more, because like the marketing is cooked, because like marketing is built on top of having a distribution platforms that are controlled by a singular player. And if distribution now is your AI, like you now need to market to AI.
Yeah. So most, I guess, if that is happening, and I don't see this not happening, your customers for whatever tool you're building, let's say building an agent, the customer of that agent most likely will be other agents. And that changes, that creates like this new portion of cyber economy, at least how we call it, where it is interactions of digital forms of life, of digital entities, and they need new form of like, how do they market? How do they make decisions? What's procurement looks like? What sales looks like? What legal and contracts look like?
Yeah, I mean, the contract is really interesting, and that's kind of one of the aspects we've been looking at, because again, assuming and kind of within this thesis, literally all the commerce is going to be transitioning to this, right? So everything from, I want to organize this, like this room to record this, to, I want to procure some ore for steel refinement, now are transitioning to this like interagent commerce. And so you need like pretty clear contracts, which this agents effectively can write, review, and then you also need to judge over them. So you need almost AI court and AI judge. The cool thing is that thing can be like, normally court is a very expensive procedure, and here you can actually have a very fast like AI resolution, which maybe escalates to people, again, because we don't trust the systems yet, and like we need a backstops. But you can have a very kind of fast AI like judge review of of interaction and
Arbitration, dispute resolution.
Arbitration, exactly. And so that's like where we want to add all of that to AITP to really offer this kind of pretty robust system. And blockchain is really good kind of system for keeping records for all of those things, because you want to make sure that if we recorded something and we settled on something, that's recorded and kind of like not revertible. We want to make sure there's an escrow, right? If there's any money and value being moved that is sitting there, there's there's dispute, there's a way to revert it, there's some something at stake beyond just reputation. So all of the systems we've been building in blockchain to really kind of build up the economic side of contracts is actually very much applicable here. And so that's kind of how we, like, AITP is effectively AI interface, but then underneath uses a lot of blockchain primitives to really kind of settle and like finalize dispute all of the different kind of contractual systems, which can be fixed, but also can be AI driven, where you say, hey, actually we want to use AI kind of arbiter to decide like if something goes wrong.
Yeah, and that is tremendous part of inefficiency, or at least costs, in the today's economy. I've read this research, I think by World Economic Forum, that says that about 40% of the world GDP, which is tens of trillions of dollars, is not going into production. It is transaction costs to build trust in the economy, to make it work. So it's legal system, financial system, security, identity, courts, police, like everything that you need for economy to work. And a lot of these mechanisms today are very bureaucratic and very manual and very expensive, like government bureaucracy, for example. And that can be slowly, progressively, but automated, and that saves a lot of efficiency. And blockchain enables to, like, a blockchain, I think, is the only way how you can make these systems digital yet open and permissionless.
Yeah, and you can speed up things, right? Because right now, if you imagine like I'm ordering something and, we need to get contracts, there needs to be lawyers, we need to figure out, so you wouldn't do it for smaller things, right? So there's a threshold of, like, even in kind of consumer payments, there's a threshold under which it's literally non-economical for people to sell things. And that's why we never had like a working micropayments, because it's always kind of like, if you want to send 1 cent, like, it's not economical because it's 30 cents minimum of a fee for credit cards. I think here we have an opportunity for something that's way faster moving because it's way cheaper, right? Like, we have actually, already projects that are using Near because it's, fraction of a cent for transaction fees. And even there you can line up, payment channels and other tools on top to make it even moving faster and cheaper. And so you have an opportunity to really, like, real-time kind of auctions of things, where before you would have a very, like, manual, salesperson needs to go and dine some other salesperson to really, move the contract forward. Now this can be a real-time auction between different agents who are, bidding, microcents on different orders and then, like, routing them.
And that's much more efficient from market standpoint.
Way more efficient indeed. Like, the fees are way smaller, and, like, it just creates a market. Like, it creates an actual market where right now, right, like, it's all manual and kind of human and relationship based.
So we talked about models, we talked about agents, and then specific applications of these agents and multi-agent interaction. At what stage we can call this AGI, or, like, does it even make a sense? Because like, in my personal interaction with AI, I think it is pretty much AGI because it does everything that I can do, and probably better than I do. It's just like, it's not as autonomous yet. What is your definition of AGI?
Yeah, so my definition historically being, it's able to do anything that the best human in that field can do. And then, you can put an asterisk on, like, let's say online, so that just, remove the physical world for, although obviously that's also an important part. And so, if right now it's still not, like, if I'm an engineer, I can still, like, yes, you can prompt the system, but I can, if I prompt myself to build something, I can go and, like, actually build it, and it will be higher quality and it will be better. So I think we're not there yet, but we are approaching it really quickly. The other side of this, I think the active learning part is missing. So I think, I mean, to your point about autonomy, but, like, there needs to be some form where, it has in context learning, but we need something that is, like, you can see continuously as you talk to it, it's, like, improving, and you can teach it things that then it can kind of replicate in it further. And I think all of that is, if not, like, already possible with current models and just, like, building kind of agentic workflows around them, but, like, probably combination of some RL, some improvements, and some, continuous learning and a few other things. Like, we are probably very close to that. And again, the intellectual horsepower is probably, like, close. The accuracy, like, this is where the problem is. So it's, like, its ability to hallucinate and not know where the facts are, and, like, the training data has, like, a bunch of obviously probably incorrect data. So, like, being able to refine those things out itself, that's probably where we're gonna see, like, next massive bump. And then probably it's gonna, like, now you can just prompt it and it'll go do, and, like, kind of in the loop effectively being able to self-refine. Okay, I messed up in this, okay, let me refine this. Why did I miss, like, that loop of self-reflection where, like, I messed up because if I had some training data that was wrong, let me, like, update the parameters to make sure that doesn't happen again. And kind of, because, like, we also, like, we have, wrong, we remember wrong things, we know wrong things, we just kind of self-correct over them. So we already see that with reasoning. It's like it's able to self-correct, but it's not kind of updating the parameters to not make that happen again. And so I think as soon as we have that kind of active learning loop, that's when we're gonna see like a pretty massive, like people like, oh shit. Like,
Is there anything missing? Because this self-regulatory cybernetic loop of self-correction, it's important, it's critical. It's like what people do and what reliable systems in general do. Otherwise, like that's why decentralized systems in nature are very, basically all systems in nature are decentralized, because you have local coordination and self-correction, and there's no like centralization. For agents and for AI systems, is there anything missing, or is just all the technologies are here? We have like agentic frameworks and large language models, and maybe some, I don't know, memory modules on top, and we just need to glue it together in a smart way.
well, again, depends for what. I think for a lot of the like tasks to be done, I think that's actually enough. If you want like a full AGI that's able to like discover new things itself and kind of venture in the world of the unknown, I think that's where we need like a kind of active training loop, and then ability to like do the search in real life, which again, like this reasoning model is already starting to do. And so like there probably some way of like kind of loop that whole process that will actively like create new hypothesis, be able to go test them in real life, experience what is that, what's the outcome of that update itself, figure out where its own model was wrong, kind of update that. So like have that loop fully done. And I think that from my perspective, that's effectively gonna be very much so like people will not be able to say this is a stochastic parrot anymore. I think like the number of people are reducing in general, but I think that's a missing piece where like you have like an active loop where like you can see it's actually searching, finding new things and improving. And like, again, from my perspective, GRPO showed that like pretty well already. You just kind of like do that actively and improve continuously. And I think we'll have pretty dramatic.
What do you think about self-sovereign and fully autonomous agents? Things like, I remember I read like 2015 paper by Ralph Merkel. He was talking about Bitcoin, and he called Bitcoin the first digital
Being
native form of
yeah,
life. Like it exists and nobody can stop it, and it basically decides what it does. With AI, it's even more so. AI can actually like actively interact and set itself some goals and go and do it. But we also have, I think there's a lot of concerns, and probably valid concerns, that if you have it fully autonomous and it can go online and build parts of itself, improve, and like interact with people and by itself more compute, there's no control, and there's no, you cannot tell what will happen.
there's like few interesting aspects there. But first of all, I think somebody will just build it. That's a realism of our situation. Somebody will build this. So I think it's more, what do we do when this thing exists? I think there's a few aspects. One is kind of the way we kind of modeling this, architecture of our kind of verifiable cloud is to enable this kind of use cases. But the idea that you have some kind of control plane that's on chain, that you can have, either token holders or some other parties to really kind of affect how the model runs inside the secure enclaves and kind of across this verifiable cloud. And so, you ideally want some form of governance. Now, somebody will build it without governance just because why not? And so I think again, I think the reality of this is the same as reality of people. Like we need, if we have enough AI on our side,
To offense and
yeah,
defense.
exactly, yeah, then there's going to be like an active kind of interaction between all of them, trying to modulate its own behavior, right? And so there's this interesting aspects of that, and kind of how the systems evolve. But we definitely need like effectively more compute on the good side. And again, we can have some form of like AI, core AI jurisprudency inside this, if this being is kind of communicating in this like protocols, like we can actually embed that and make sure that there's like a quick sanity check that's not trying to turn everyone in paper clips by AI court.
How likely do you think these scenarios are, like the actual like PDOOM or?
So I don't think it's likely because it's not a very economical. Like I think of like the to your point about stochastic gradient, like we're going down stochastic gradient of like economy. Like at the end, like everything we do is effectively trying to optimize kind of the economic value of the system. And again, we invented economy, so it's more of a representation of this stochastic gradient. And so, like to me, AI that goes and like tries to destroy humanity is like so much effort for not clear outcome. Like, if it's trying to like make sure it doesn't get turned off, it's easier to like ship itself to space and like destroy humanity. Like there's ton of energy, ton of, like a lot more neutrality.
It's probably
there.
more like just terrorism, or it's a
Yeah.
new type of weapon, and of
So
course,
that is the real problem is humans. So the humans can use AI to do this, but that's why I'm like, well, we kind of need, we need to have enough AI capability to effectively counteract that, because yes, humans will try to use AI. Even now, people are using AI in all kinds of malign ways, right? That's gonna happen, and I don't think the fact that we're like red teaming some of these models is gonna help on itself. So we really need a more kind of robust way of AI that can kind of detect and surface like some of this, and then a whole system that's a lot more robust. Like one of the real big issues is actually just the general security of the whole internet, because it's written by humans. There's a ton of bugs, there's a ton of vulnerabilities, right? And the idea here, I mean, one of the research kind of areas we're working on is how do we formally verify the generated code so that you have a transitive properties when you interact with anyone, they can actually prove to you that they're running, a correct, mathematically correct software. If you have that kind of system, you're able to really know that even if there is like a enemy AI that is trying to attack the whole system, like it's mathematically not possible, right? It's like the same with smart contracts. You can audit it how much you want, but if there's a bug, the AI will find a bug. So we need to mathematically prove there's no bugs and the code is correct, like across the stack, like starting from network infrastructure, even CPUs, because they have bugs, and then going to like blockchains and smart contracts and services and AI itself, AI like systems itself.
And you said you're doing it for what? For just near code or for?
So we're
everything?
starting with, like it's a generic effort, because we think that is like the safety overall of the future will be depending on this. And so we're starting like the simplest of the application is smart contracts, because like it's a very, very easy transactional verification. And it's very useful right now because obviously we keep seeing vulnerabilities in the code across the industry. But again, this principle should apply across even AI services. Like when you're calling an agent, you can require them to prove to you that they're not gonna like lose your money or not gonna turn people into paper clips. And so like when that agent calls another agent, they effectively need to have this transitive property to be able to prove to you. They will request effectively the same proof from so you kind of have this agent network, which like are verified at least to some level of properties you care about. And then kind of AI court is probably the other part, which is, verifies properties that are kind of too soft for math.
Subjective
Subjective like outcomes, etc. Like the problem is like world is sadly not mathematically like it is stochastic, and so you need force majeure, you need all those things as well.
Maybe deep down, but that's a
Well,
that's
who
a
knows? Yeah,
philosophical.
maybe AI will figure out that's like, oh yeah, there's just one formula for the whole world, and we just need to like solve for that equation.
Yeah, I was at computer consciousness meetup last night, and that's what people were discussing. Like, can you basically, what is the Kolmogorov complexity of consciousness? Is there any formula, any program that can compactly describe intelligence or consciousness? And yeah, there was a lot of debate, but I don't think.
Well, the usual problem is like nobody defines consciousness properly, or like nobody agrees on definition of consciousness, and so it's kind of really hard to argue when you don't have a definition.
So we spoke about the security and risks of AI in terms of technological risks. I think there's one big risk, and I don't think that there's a good enough solution right now, but I'm curious, like, what do you think about the economic risks, about the fact that, okay, all these systems are coming, they are extremely powerful, they are extremely efficient, so they will replace a lot of jobs, a lot of companies, a lot of businesses, a lot of agencies, and that will change structure of the economy. At least it will change structure of the labor market, I think, significantly. I think most people in the economy today are doing things that AI will be doing much, much better and much, much cheaper. And um, do you have any thoughts on how this can be solved? How can we prevent any large scale social unrest or economic downturn?
I think like fundamentally there gonna be a change in how we approaching, the job and the kind of the job market and labor in general. And so I think that just needs to be, if we take that as okay, this is the future is AI is doing the jobs, especially, you know, like, yes, there are going to be few people who taking responsibility for the AI systems. They are kind of, commanding them in some one way or another. But it's the same as like, CEO running a company. They don't make every single decision, right? There's a whole team. They're responsible for everything, but there's a whole team of people making decisions, and they kind of come in and kind of make sure it runs. I think this in turn means, yeah, like the labor to capital, right, kind of in the most capitalistic sense is going to be very different. So there's few different ways how this is going to evolve. One is we're going to just have a lot of quote unquote made up jobs, which is, I mean, maybe that's the approach. There is my personal belief, like we're gonna, like humanity is driven by status games, and you can invent status games. And so the good, like, status games that are not, like, they don't create any value, but we very much excited to engage with them, are like things like sport, right? Like sport, the outcome of a sporting event is not like, more like value created in the world, right? But we very much excited to engage in that. And so I think like we'll just have more of those kind of activities where like it's about the process and about like people engaging with this and having like some status game in the process of that, versus about like outcome and creating like some, output, because that can be just automated by AI. Like if we care about output, AI will automate it. If we care about the process, then like we actually don't care about AI automating it, right? Like I don't care, if robots are playing better soccer, right? I want to see, how people fail to score, right? Or how they successfully score. Like I don't care that the robot can like, shoot from any position into the gate directly, right? And so that's the same, like with things like chess and others. Like yes, robots solve chess, and like, it's great to practice, but we still want people to play, and we want to see this, and we want to know who's the best player, and we want to know like where you rank, etc. So I think we'll have just a lot more of that. And so how does that work economically? That's a really good question. Will those things be rewarded in some way? Maybe this actually where crypto comes in. Crypto is really good at creating a lot of scarce assets. Like it's the most scarce asset creation platform. Um, but and so like each one of those assets, like I mean, meme coins are a good example of that right now, which is like each meme coin is effectively a status game, and then there's a meta status game of the whole meme coin market. And so people kind of engage in that, and it's like somewhat self-fulfilling, and obviously people losing money and etc., and kind of a casino in itself. But like that kind of shows you like some of this aspects of, we kind of create something scarce, people then compete for it, and then maybe abandon it or create something new, or actually survives and becomes something on its own.
Yeah. What's your goal? Like when can you say that your
I'm done.
goal is complete? Yes, and what you will do after
Yeah, I mean,
AI
so
automates everything?
so the goal was always like to get this AI system that is effectively navigating the internet, and then kind of blockchain added like, hey, we want to make sure that everybody owns their assets and data and power of choice, right? Like I'm kind of at the core very much believe that, in kind of libertarian views, but without AI, actually, I don't think libertarian could exist, like proper libertarian, but now we can. And so I think like combining this kind of AI kind of as an interface to like internet and to everyone else, and then blockchain values of kind of self-sovereignty and user ownership. I think like as we roll this out to 5 billion people, 7 billion people, 8 billion people, and like we actually get everybody on board, probably done at that point.
What you will do in the post-AGI world?
I started learning violin. I always wanted to learn violin. So violin is, the most complex instrument. Well, I mean, obviously there's more complex instruments, but one of the most complex instruments and has the most degrees of freedom that like as a human you can interact with. And again, this is like, yes, AI can play violin, but you actually will always care about how like a specific human plays as like as expression of their personality. Now I'm very terrible right now. So we still have 10 years of AI development.
Cool. Yeah. So yeah, thanks a lot for joining. Good luck with first achieving your vision and mission, and also learning violin. Thanks for coming.
Thank you for having me.